Good afternoon, Chris Douglas, Hillsborough County Fire Rescue, Station 38, A shift, driver engineer. Here today to talk to you guys about operating our Pierce fire trucks in a tank to pump capacity and deploying one single hand line. This will be helpful and useful for some of our newer members that are starting the driver engineer checkoff process. So one of the biggest things we want to do initially when we pull up on an emergency scene is we're going to bring the truck to a stop. We're going to put the truck in neutral. We're going to go ahead and pull our air brake at that time. Once that is set, you will see that the driver engineer will place their foot on the brake pedal for constant control of that system. At that time, they will use the actuator to go from road to pump. So as it comes down to the initial neutral setting, there will be a pause of about 3 to 5 seconds. Once we get the okay, we're going down and we're gonna set the pump into actual PTO pump mode. Once that is set, the driver engineer will set the truck in drive, which you will see will not only give you an indicator on miles per hour and RPMs, but will also on the Pierce Sabers give you a digital indicator that the truck is engaged in pump gear on the screen itself. Once that's completed, you will see that our firefighter is going to deploy one of our 200-foot sections of 1.75" hose with 150 GPM Chief Elkhart brass nozzle. Once he starts deploying the hose, one thing to keep in mind as you're going through this process is it's the driver engineer's responsibility, being in charge of that apparatus on this type of scene, to constantly make sure that hose bed is cleared. That will be that driver coming behind the firefighter, making sure all the hose is cleared from that bed section, that cross lay section, and then that first 50 to 100 feet that leaves the apparatus, that driver engineer being responsible for making sure that hose is set up in a way that we lessen our friction loss on scene. Obviously, we're using 1.75" hose here at Hillsborough County Fire Rescue. It is a small diameter hose, so it comes with a large amount of friction loss. So as that driver comes behind the firefighter, establishing a clear hose path to the scene, this is going to allow that driver engineer to calculate and understand their friction loss in a more clear visual picture as they actually send water from the fire truck to the firefighter operating that hose line. So at that point, once the firefighter has cleared all the hose, it is always important to take an extra few seconds to go to the cross-lay bed, and at that point, double verify which section it is you will be charging to that firefighter or those individuals on scene. Once we verify that, we're going to go up to the pump panel. We're going to initiate our tank to pump. Once we initiate our tank to pump, we are telling the truck that we are establishing that we are going to work from a tank water source. We do not have a static source. We do not have an external water source like a fire hydrant. We are working off this tank and we are going to pump it directly to that given hose line. So once tank to pump is pulled, this is where we want to go to our TPG, which is our pressure governor, and we're gonna want to make sure it is set in PSI mode. We are not doing drafting. We're not in a relay mode. We're not pumping another apparatus. This is a single line, so we want to make sure we're in PSI mode. Once we manually set that TPG into PSI mode, at this point, we have a preset button that is established where here on engine 10, it is preset at 90 PSI, which for our 200 feet of 1.75", that is our given go-to pump chart setting is 90 PSI. We have that option for setting our PSI. If that is not the choice you have, you also have the choice to manually increase your PSI to your given rate per your pump chart. Understand, before you set your PSI, we want to go ahead and actuate that line. We want to send water to that line, more so for the sole purpose of making sure that we're not charging hose at 90 to 100 PSI and causing more friction loss with kinks, with hose making its way under the truck or possibly getting caught under a tire. So once the water is actually sent through that piping, it's sent through the pump to that fire hose. At that point, once we initiated that, we can go ahead and increase our PSI to 90. Once the firefighter starts initiating their attack on the fire, it is the driver engineer's thought process that needs to kick in, that they are flowing that nozzle at 150 GPMs. With these Pierce Sabers are gonna be 750 gallons attached to these trucks. So theoretically, we have about 4 to 5 minutes of full capacity flow before we run out of water on scene. So we want to take time to think about what external water source is near us, whether that will be a second due engine company that will be coming on scene to give us their 750 gallons, that next due engine company that will be catching a hydrant, delivering us an external source, or if we're getting into situations associated with drafting. So at that time, we want to make sure that we're calculating how much water we're putting out, what type of structure is involved, residential, commercial, industrial, how close our next due units are, and where our next hydrants will be. But pumping off this single tank source will give us about 4 to 5 minutes of uninterrupted flow to reach that 750 gallon capacity. So at that time, once we have that established, the firefighter is going to continue that flow until we find an external source to attach to our truck to continue water flow on operations, or to take multiple lines out at that point. Also keep in mind, as we are flowing water from the tank through the pump, we're going to always pay attention to our master discharge gauges, but also once this line is initiated, not only do we want to keep in mind that master discharge gauge, but we also want to watch our individual gauges. All of our gauges individually will show us this 200-foot section of 1 3/4 individual pressure. So that's where we may be pumping a little bit higher on that master discharge to get the pressure that we want on this 1 3/4 line due to additional unforeseen friction loss.